Perhaps you've tried to draw a 3D room, but where would you start? Turns out there's a technique. If we randomly draw a point called the vanishing point on the page, draw objects in the room, and extend some edges of the object to intersect this vanishing point, then we can get something that looks 3D. Add a few more objects, and the room has much more depth. But why does this work? Well, to explain, let's study a field of mathematics known as projective geometry. Projective geometry is where we study how different objects project onto different surfaces, as well as which features remain constant under a projection. Like if I drew a cross, even if I change my perspective, the intersection of the cross will still be there, although the shape and the size of the cross may be different. Now let's understand how to project an object. Say this red point O here is our eyes, this orange plane is our paper or what we see, and these points P, Q, and R on the green plane are parts of the object we want to draw onto the page. If we connect these points to O, the points at which the lines intersect our paper, P prime, Q prime, and R prime is where we draw the object. Let's look at another case. Here are a pair of parallel lines. Technically, parallel lines should never converge, but they do in projective geometry, which uses a projective space. This may sound a bit impossible at first, but it's actually not a new concept. Well, why do they appear to intersect? That's because the projective space is different from the Euclidean space that you might be familiar with, in that it disregards distance and also has points at infinity. Again, we do what we did above and project our parallel lines to our image plane, and you'll notice that the projection appeared to converge. Mathematicians call this the point at infinity. Alright, now that we know this, what exactly do we do before and how is this all connected? Well, since we know that all parallel lines converge at infinity, then we can draw planes that are made up of parallel lines. So in fact, the vanishing point is actually the point at infinity, and since simple objects like cubes are composed of parallel lines, some of their sides need to converge at the vanishing point to make the object appear 3D. What we covered is just barely scratching the surfaces of this field of mathematics. If we were to extend the application, this can be used in satellite imaging, in the games we play, and other fields in mathematics. And all of this from just trying to draw an object onto a piece of paper.